Bonjour à tous et bienvenue à Alberton School Laval. Aujourd'hui est un grand jour puisque nous assistons au démo day de nos étudiants en spécialisation cybersécurité. Il s'agit de William Granger et Solomon William. Ces étudiants ont tout d'abord réalisé le cursus fondamentaux du développement informatique qui équivaut à la première année d'Alberton School. Puis, ils ont décidé ensuite de se spécialiser en cybersécurité. C'est une spécialisation qu'on a ouverte depuis peu de temps. Effectivement, la cybersécurité est un sujet très actuel. Nous subissons de plus en plus de cyberattaques, que ce soit au sein des entreprises, auprès des particuliers et même des gouvernements. C'est pourquoi les étudiants peuvent se former désormais à la cybersécurité à Alberton School. Nous avons le plaisir d'accueillir pour ce démo des jurés professionnels Antoine Fouilleul, RSSI à Lumines, et Jean Godot, ingénieur d'application à All4Tech. Le regard des professionnels est très important et va permettre à nos étudiants de se challenger techniquement. Pendant cette spécialisation, ils sont montés en compétences au sujet de la protection de systèmes d'information, la détection d'intrusions, la sécurité des réseaux. Et aujourd'hui, ils nous présentent leur projet, un projet dédié à l'Honeypot, pot de miel, qui est en fait un piège pour les hackers. Je n'en dis pas plus et je laisse la parole à Solomon et William.
Merci. Thank you. Hello, everyone, and welcome to our cybersecurity portfolio project. Today, we're going to be presenting our custom honeypot. My name is Solomon William, Laval C22, and I'm a cybersecurity student.
Hello guys, I am William Granger. I'm also a cybersecurity student at Laval, and I'm proud to present you our project.
So first of all, let's start off with what is a honeypot. So a honeypot is a cybersecurity system. It's intentionally designed to appear vulnerable to attract attackers. When attackers do malicious actions, we record and analyze the data. And the goal is to get some insights into their attack and secure a real system if we have one. What inspired us to do this project? In our curriculum, we were given a list of projects to choose from for our portfolio. That included red team projects, blue team, and cyber intelligence. And we chose a honeypot because it struck a good balance between the three. It's a blue team project, but we could also undertake some red team actions by testing it ourselves. We can collect and analyze data, which is a bit of cyber intelligence, and the main goal is to use the insights to protect real systems.
Okay, so just to add some more context, we deployed two servers. So one server is our main server, so we host the 4 honeypots for 4 different protocols, which are SSH, HTTP, HTTPS, and SMTP. And then we have another server to store and register and store the logs. It's kind of a security measure in the case that if we lose the access of the main server, we can still see what happened on our second server. So yeah, we can go to the technologies. Okay, so for the technologies we used, we mainly use DigitalOcean to have our own servers, so two. We configure them using DigitalOcean. We also use Kali Linux, of course, Bash for the scripts, Python as well. We mainly use Docker for the containers of the honeypots and the ELK stacks, so Elasticsearch, Logstash, and Kibana. So for the architecture, we use the defensive depth strategy. So we have 3 layers of firewalls. So the first layer is the network layer with DigitalOcean firewall that we configured on their website. The second layer is the host layer, so on the Ubuntu server and our UFW rules. And then we have the application layer with SSHD. So to prevent anyone brute forcing their way to our admin shell, because yeah, I will talk to it just after. But we have an admit shell to like manage our honeypots and our logs. We have a custom port that attackers won't be able to scan, that it will not appear from a network scan. And without that secret port, the attackers are redirect to the honeypots. So depending on which protocol they used. So for the protocol SSH and on port 22 we have Cowrie. On the protocol HTTP and on port 80 we have Tanner. On protocol 443 we have on protocol HTTPS and on port 443 we have our custom honeypots that we made. And for the SMTP we have Mailoni and on port 587. I can add as well that we are registering the action in the logs even in the main server. So we have a Docker container just for this purpose. And then, as I said, we store the logs as we send, and we store the logs on the second server just for security measure. So now we will show you the live demo. You start?
Okay,
or,
yeah.
I do.
Yeah, I'll start. Sorry, my Kali Linux is a bit slow at the moment. I'll make this bigger.
Yeah,
Okay,
the
it's not
screen sharing
resizing.
plus the VM, sometimes it's laggy.
Okay, I'll start while it's loading up. So this is our dashboard where we can monitor all of our honeypots. This is the Kibana dashboard. It's part of the ELK stack. So at the moment we're looking at the last 24 hours. You can see we've had 18,000 attacks by SSH and about 500 on HTTP, 50 on SMTP, and we have a few visualizations as well. We have an attack map that shows the source of the attack, as well as like the different ports that have been used. Another interesting chart that we have is this username and password tag cloud. So if we were to click on a username, we could see the passwords that were associated with that username in terms of brute forcing. So that was the dashboard as a whole, and now we'll look at some of the honeypots.
Close it.
So totally frozen. So yeah, we're just waiting for the VM to pick up. Okay, so this is our custom-made HTTPS honeypot. You can see it's just a single-page login template. And if I were to input some commands and make a request, you'll see that I'll get the logs on both our honeypot server and our backup server as well. So we'll quickly take a look at a log that I just sent. So we can see that the last log was the one that I just sent. And we also have the same for HTTP as well. So if I was to go to, so this is our TTP template. It's part of the Tanner honeypot. And we actually get a different template every day. So today it seems like it's kind of a wiki page. And if I make a request, and if I go back to our server, sorry, that was the Tanner log that I just sent.
It's fine, it's fine.
Okay, we switched up HTTP and HTTPS, but yeah, that one was the last log that I just sent. So yeah, that was the HTTP log, and I can refresh it as well. So yeah, that was actually the last log that I just sent for HTTP. So now we'll move on and we'll look at the SSH and SMTP honeypots. So,
Okay, so now I'm gonna show you the Mailoni honeypot, which is on port 587. I'm sorry, I'm not used to this keyboard. Can you type the double points? The two dots. So right now I'm entering the email of the victim, the potential victim. So the content of the mail will be test, but you can actually put some phishing inside of it. And then we are gonna see the logs just right now. Okay, so sorry for the time I took. So here is the mail I just sent. So we get my current IP, which I can the 90.40. So it's my current IP, as you can see right now. So yeah, my current IP is 90.40, etc. So that's how you know that it's the mail I just sent from the honeypot. So the mail from you have the sender and the receiver and the content, which was test test test. So that's it for mail learning. Now I'm gonna show you the honeypot on port 22, which is Kauri. So if someone tries to log in to our server, like he just did some scans and he witnesses a new server, he will try to brute force.
Define the username.
Oh, yeah, yeah. Okay, so let's say someone tries to brute force our server with the username Bob. So he has to enter a password. So let's say, I don't know, the password will be lol. So he got connection refused. So what happened? So we registered this information. We have it in the logs, but for testing purposes, we have a whitelist in our user DBs for these honeypots. So we want people to access the honeypots without being it to be like free. So we have a small whitelist, but with easy username combinations and password like Bob, root, and some kind of stuff like this. So people have to brute force a bit, but they will get access if they want to. So we can like investigate and learn from their actions. So the password of Bob is Bob. Yeah. So let's say Bob is on the server. He wants to type some commands. He wants to, I don't know, create a directory. Okay, so we're gonna see all of he did in the logs.
One thing that I'll just add about the port 22 honeypot is that all the responses that the attacker will see are entirely fake. All of their commands, they don't really do anything as well. Kauri is also very customizable, so we can also create like our own custom file system, place some files and directories so that the user thinks, or the attacker thinks, that this is a certain type of machine running certain types of services.
And as you can see, we got the first log of Bob. The first Bob was this one. So you got the event ID, Kauri login failed, username. I don't know if you can see. I hope you can see. Login failed, username Bob, password lol. So that's what I just showed you. You have the timestamp as well. You have the censure and the session ID. Of course, the IP is the same. And then the next log is the login success. I can also grep by command. Sorry. So yeah, so the last command input in our honeypot was mkdir lol, so the one I just did in front of you. So yeah, everything is working fine.
Okay, so that was a quick demonstration of the honeypots, and now we'll continue with the rest of the presentation. Okay, so during the whole process, we were continuously monitoring logs, and now we'll look at what did we learn from the data that we collected. And there's two really interesting cases, and these are real-life cases as well, from real attackers. We'll look at two of them quickly. The first one was a SMS infrastructure and reconnaissance and device enumeration. That one was really interesting because we saw some commands that we've never seen before. And the second one was a brute forcing attack, which was also really interesting, but we'll talk about that one later.
So yeah, for the case study number one, we were investigating, monitoring, our logs for Corey, and I've seen some curious inputs from a Korean guy, the guy you can see on the screenshots. Like it was some really new commands we never seen before. So we tried to investigate about this guy, and then we discovered that this guy has been reported more than 25k times. His IP is on DNS blocklist, so he's been doing like naughty stuff online for sure. So that is the guy that we will talk about in the few minutes.
Okay, the second case that we saw was a brute forcing attack, and this one really kind of confused us as well because our server wasn't really that powerful. We had like 8 gigs of RAM. So the attacker, who was his IP address came from Poland, he did about 80,000 SSH attempts, connection attempts, password and username brute forcing, and we think unintentionally it kind of turned into a DOS attack, a denial of service as well. So it took a while for us to figure that one out. But let's start looking at case number one, and we'll look at the first log that we saw from the attacker from Korea. So the first thing we see is the initial connect. Then we have the session encryption key, and we can see next to this white arrow the username and password that he used to log in to the shell, the fake shell. And he used the username and password root, which we put in intentionally, made it weak so that he could connect.
So for the first command the attacker used was /IP cloud print. So he got a command not found, but why? Because this command is only available in MikroTik router OS. So it is this kind of syntax, so that's why it's not working in the shell environment. And then we guess that he did that because after investigation, of course, the MikroTik router OS is weak in terms of security in 2025. So I guess if the command was responding, he would like try to maybe steal data, install a backdoor for remote management, or maybe just enumerate DNS settings. So yeah, that was his first command.
The second command he did was ifconfig, and he did this to list the network setup, network interfaces, and NAT settings. So this is after his first command didn't work. So we're also analyzing his behavior as well. So the output of the ifconfig that he would have seen would have been really interesting. It doesn't show any real data because it's a fake shell, and it's highly customizable as well. So we could customize it so that he sees basically what we want, and he can follow in the steps. At the moment, the default output for ifconfig with Cowrie is some random information, but it looks real. So fake, random, and looks real is the output.
For the next command the attacker used was uname option A. So at this point, we think he wanted to see if he was in a honeypot or not. So he's just doing a system reconnaissance. So at this point, he wanted to get information like kernel name, host name, what kind of OS, and what kind of hardware. But we will see in the next slide. In the next slide, it's just another example of the attacker doing system reconnaissance. So he is looking for CPU information at this point. but we were like lost. Like, why would he look for this kind of information? But apparently, sometimes the basic honeypot specs, when you are in a honeypot and you list CPU info, sometimes you only see like one CPU core in the shell. So it's one of the tools, one of the hint, a clue, I would say, the attackers are looking for, just to be sure that they are in a honeypot. But as Solomon said just before, it's in Kaori honeypot, it's highly customizable. So now that we knew that the attackers could look for this kind of information, we can like manage it and do it as we want.
So the next command that he did was checking processes for anything titled minor. And as well as with all the commands that we did, we can't really say for sure what he's trying to do, but we can only make an assumption based on the behavior. So it looks like he's checking if this device is currently being used for crypto mining or if it has the capacity to be used. It's possible that he might have wanted to kill the process and set up his own miner as well.
And for one of the last input he made, he was searching for scenes of GSM modem or SMS gateway structure. So the goal, we think, we just have to guess because we have no proof, but we think the goal of this kind of search are to send multiple phishing SMS, so that we call smishing. So I think at this point we were like 99% sure this guy was not doesn't have good intentions.
I'll just add on what you just said. He also could have used the SMS infrastructure for like controlling malware in like a C2 command and control server. But yeah, there wasn't anything on. We don't have any directories or files like that on the system. So at this point, he probably realized he was inside a honeypot, and his final command was just like echo hi, and then he disconnected. We can confirm that it's a human attacker because usually scripts don't really end, an automated script wouldn't end with hi. Well, not usually. And also we have these TTY logs for each command. And there is a function with Kaori. We have an executable, and if we provide the file as an argument, we can kind of see his keystrokes in real time. So that's how we can confirm that this was a human attacker and not a script. So the second interesting attack that we wanted to look at was the brute forcing attack. Do you want to give any backstory on it?
So the brute force attack, at first we didn't know it was even a brute force attack. We were on the server, and then everything got laggy, but really laggy, like 5 minutes to enter a command. And then we went to our DigitalOcean dashboard, and then we've seen that our CPU is going above 100% usage. So we were asking ourselves, what happened to the server? Are we getting DDoS or something like this? And then we went to our Kibana dashboard, and we seen NIP doing more than 70k requests. So he was really brute forcing his way to the server. But because our specs were kind of weak, he doesn't mean to DDoS us. Just the server was just too weak. So yeah, everything got laggy because of this kind of brute force.
And this was a really interesting attack because it didn't just affect the honeypot, but it infected the entire server. So we had to do some really some good investigation to figure out what was going on with that one. So now that we've analyzed the commands and the attacker's behavior, we'd like to provide some mitigation strategy to defend against this type of enumeration. And just to clarify, when we say mitigation strategies, we don't really mean it for our honeypot. We mean it in the fact that if we had a real system to protect, that's what we would try to harden. So the first, we propose a defense in depth strategy. So basically what that means is we have multiple layers of defenses. If one fails, then they'll have to go through another one as well. So the first one we propose is a network firewall. We can whitelist certain IP addresses to the SSH port and drop all the other connections. The second layer of defense we recommend is a OS firewall. It does the same thing, but on the network level. So if the attacker somehow does bypass the network firewall, they might get blocked by the OS firewall. We can also implement intrusion detection systems just to block IP addresses after a certain amount of failed attempts.
We can also add the application security, which we used, but yeah, we recommend it because even if the attacker goes through every other layer, he will have to be like on the whitelist to access the server. We also recommend the SSH key authentication. The SSH key authentication is made like you have a public key and then you need to have the second key to make a connection. If you have only one part of the key, you cannot connect. And as well as the MFA. So MFA means multi-factor authentication. So I think maybe a lot of you know it now, but the goal is like when you want to authenticate to a site or something, you can receive an alert by mail or by phone, and you have to confirm it. So it's just another layer of security, as well as the system information and event monitoring. So by that we are meaning a dashboard, just like the ELK stack is offering with Kibana. This kind of dashboard is really practical to monitor.
So now we'll just talk about the timeline of the project. So in the first week, week number one, we created our first server and set up the server hardening for our own admin access. So yeah, that was really good. At that time, we were really happy to start hardening our server, so we actually locked ourselves out at the same time. So yeah, that was quite funny. The second week we started deploying honeypots, and we even created the HTTPS honeypot from scratch as well. Third week we created a second server where we send all of our logs over there as a backup. And we did that just in case something happens to the main server. Let's say someone attacks the actual admin access for us and we lose our logs. We have a backup. Yeah, the last weeks we were just continuously monitoring the logs. That's how we found out about the two interesting ones, and preparing our presentation, as well as some quick fixes. So challenges and improvements. One of the challenges we faced was kind of learning new technologies. We used Docker a lot in this project, and it's not something that we used before. But yeah, to overcome that, we just used the Holberton framework. We went in with a plan. We did pair programming. We did a lot of meetings, like in the mode of stand up and SOD, and yeah, it was. Yeah, we were able to manage the learning curve as well.
I will add as a challenge, in this year we never actually worked on the live server, our main live server, so it was kind of a very good experience as well as a big challenge because as Solomon said, like not the first day but in the 2 or 3 first day we got locked out from the server because we went too fast and we didn't read anything, so we were just happy to manage our server, but we went really too fast. So that was kind of a challenge to configure it really well, know what we were doing, configure the honeypots. We, as Solomon said before, we customed a honeypot on the port of our tree because we could have just take a random honeypot which is already existing on the net, but we wanted to have some specifics input and some specific, how can I say, like options. So we did one ourselves. As well, another challenge, I would say, the logs sending, like the log registering, sorry, and sending to another server. That was kind of a big challenge. What else in improvements? You want to start, Solo?
Yep.
Yeah.
I think one of the improvements that I would like to make personally is like kind of customizing our file system. As I said before with case study number 1, we could have placed like certain files and directories to make him think that there was a server, specific service, and we could have followed the attack like at another level, like one more level in. Another improvement could be the server that we had. It was really weak, which gave us the kind of unintentional DOS attack. As well as one of the most interesting honeypots was SSH Kauri, and because it's like really customizable, we could have like modified the output for like enumeration. So for like uname, ifconfig, we could have made the attacker think that he's on a particular device. So we could have set this shell up as a MikroTik device, and yeah, we could have followed him even further.
Yeah, I will say kind of the same. Just improve the credibility of the honeypots, like each honeypot, especially Kauri, because with Kauri, yeah, it's highly customizable. We could have had the attacker, the Korean guy attacker who was looking for cryptocurrency mining stuff. We could have had this kind of fake processes. So yeah, I would say improve the credibility in terms of improvements, as well as maybe fake DBs, fake user DBs in most of the honeypots will be a good improvement as well.
I think a more intricate front-facing site would have been good as well. More pages, more fields. We could have got more like web attacks as well, because at the moment we got mostly SSH attacks. So that's all for us for the formal part of our presentation. We hope you enjoyed it, and we've left our IP address up if you'd like to attack it. If you'd like to discuss your attack with us as well, feel free.
Thanks for watching.
Thank you.
Thank you, guys. Good job. We have only 5 minutes for question, so we can go.
In English?
Yeah,
I guess.
firstly.
Okay. Thank you for this presentation. My first question is about you explained two cases of attack on your endpoint. One I think is missing is about vulnerabilities on a version of your service you exposed. Did you get some attack on specific version of maybe Apache, maybe SSH or something like that, or SMTP?
So at the moment we just deployed like the default version of each honeypot. So like the default version of Kauri, Tana, and Meloni. So we didn't really check the logs for like specific versions, but more for like the attacks as a whole, like specific types of attacks that we get. Anything you'd like to add, William?
I think that's clear for me.
No problem. Okay, thank you for the presentation. Yes, it's not a question specific to the honeypot, but a question about the dashboard. So how do you update the dashboard? So is it in real time? You check the logs? How it works? How do you update the dashboard? And the question is, how do you analyze the log? Because maybe the risk is to have, how you say, not real how do you say, not a log which is not interesting, so you have to choose which one you want to present in the dashboard, maybe the one that you don't want to present because it's not important. So you have do you apply automatic analysis on your logs, and yes, how do you produce this dashboard and how it is connected to the logs, please?
Okay, good question. So I'd say for the dashboard, we mainly used Kibana. It refreshes itself like every second or a minute. You can manage it yourself. But us, we mostly focused on managing the logs ourselves manually. So in the case that we don't want to see these logs, if we get 10K logs, of course we are not gonna go through the 10K. So we filter manually with the grep. But still, if we see a pattern interesting, like for the Korean guy example of the Polish guy, we just investigate about him, this IP, this session ID, the container. We can get the container number. When the container of a honeypot is running, there's a number affiliated to it. So we know for this timestamp, like we just investigate and we conclude that okay, we have an interesting pattern, and then we save the information we have to learn. I don't know if it answers your question.
Jean-Alain? We can speak in French if you want.
Ok. Par rapport à tous les honeypots qui existent, en fait, qu'est-ce que le vôtre apporte en plus? Enfin, quelle est la nouveauté? Qu'est-ce qui fait que le vôtre sera plus intéressant, par exemple, que d'autres honeypots déjà existants?
Alors, nos honeypots sont pour le coup assez classiques. On pourrait les améliorer et les rendre encore mieux. C'est vrai que là, on a eu un temps assez court quand même pour ce genre de truc. Mais tu as raison, on pourrait les améliorer, les rendre mieux. Et du coup, avec les choses qu'on citait juste avant, tu sais, avoir des fake DB, customiser, mettre du contenu complètement faux pour que quand une personne consulte un honeypot, il pense qu'il n'est pas dans un honeypot. Maintenant, on attend juste d'avoir des meilleures attaques et pouvoir, en voyant ce que les gens cherchent et en analysant les logs, on peut améliorer, on pourra toujours améliorer de mieux en mieux dans les limites de nos connaissances pour l'instant, mais on pourra toujours les améliorer pour les rendre mieux que la moyenne, on espère.
Dans votre tech stack, j'ai vu que vous utilisez Elasticsearch. Du coup, ma question, c'est en fait, est-ce que vous pouvez rechercher par exemple par mots-clés des choses dans vos dashboards ou quoi? Parce que j'imagine, est-ce que vous aussi d'ailleurs, en analysant des logs et en détectant des patterns, vous vous êtes pas dit, tiens, ces mots-clés-là, on va les taper, comme ça nous permet de remonter des informations intéressantes ou...
Je vais répondre en anglais si possible, Florian. Merci. So with Elasticsearch, we use the so above Elasticsearch, we use kind of like a honeypot framework called Teapot, where you can deploy and install multiple honeypots as well as the LKA stack. So one of the default settings is it comes with like some keywords, and I forgot what the phrase was. You know
Keyword is good.
I think keywords is good. Came with some keywords that we could search for and some predefined filters. So and there was quite a lot of them. So we could search by session ID, session cookie, commands, inputs, timestamps, and so on. And I hope that answers your question, Florian. Merci.
Dernière question, on respecte notre timing. Côté juré, côté Gwendal, Jean-Alain.
Du coup, j'aimerais savoir quel type de données un attaquant pourrait récupérer en infiltrant honeypot.
Alors, en fait, les seules données qu'il pourrait récupérer, c'est les données que nous, on entrerait. Parce que... Attends, je réponds en français ou... Ouais. Les seules données qu'il pourrait récupérer, c'est les données que nous, on a choisi d'afficher tout simplement. En fait, l'intégralité de ce qu'il y a dans le honeypot est fake. Et donc, il n'y a rien à apprendre tout simplement. C'est comme s'il arrive, il rentre dans un appartement, mais tout est faux, quoi. Donc il n'y a rien à dérober.
Très bien. Merci beaucoup à tous les deux. On peut encore vous applaudir, je pense. Bravo pour votre travail et votre parcours. On va clôturer ce démo par un mot de la part d'Axel, référent technique et pédagogique, qui a su aussi vous accompagner pendant cette spécialisation. Je te laisse la parole et la place, Axel.
Ouais, un mot. J'avoue que ça me tient à cœur de vous donner un mot pour le coup, parce que félicitations. En vrai, vous êtes les premières personnes à passer, en tout cas la première cohorte à passer un démo day, ce que je disais d'ailleurs au juré, en spécialisation cybersécurité. Donc vous n'avez pas eu non plus énormément de monde sur qui vous appuyer, c'était pas simple, et vous avez eu 4 semaines pour réaliser ça. Alors j'ai pas toutes les compétences techniques pour évaluer tout ça, mais je pense quand même que vous avez été très investis. Les mentors techniques hier l'ont quand même souligné. Donc moi je tenais vraiment à vous féliciter. Et très content de vous voir réaliser tout ça et de sentir aussi un petit peu la ferveur autour de votre projet. Moi, je l'ai ressenti lors des Demo Day, donc bravo encore. C'est cool en plus de te voir, William. On a commencé dans la même cohorte, donc ça fait plaisir. Ça fait plaisir. C'est 18. Mais oui, Solomon aussi. Voilà.
Très bien. Merci à tous, en tout cas, pour votre participation cet après-midi aux démos de nos étudiants. Encore bravo à tous les deux. Et puis, en direct, on se retrouve dans 2 mois pour le prochain démo day de nos chers C25. À bientôt.